Hello, everybody. This is the first video to go with section 15, which is on quadratic functions. And we've been saying this term throughout section 14 when we were learning how to factor quadratics, that a quadratic function is in the form ax squared plus bx plus c. And we haven't really specified that a can't equal 0. Specifically, the reason that a can't equal 0 is because if there was no x squared term, then this would not be a quadratic, because a quadratic, the formal definition is that it's a high power of 2 on the variable. So the fact that this is an x squared is what's making this a quadratic function. The graphs of quadratic functions are U-shaped graphs. They're either an upwards facing U or a downwards facing U, okay, like a mountain. And they're called parabolas. So the graphs of quadratics are called parabolas. And you can tell which way a parabola is going to face by the function. Turns out that the value of A, the A piece, tells you which way it's going to face. If A is positive, the parabola faces up. It's going to be a regular U-shaped graph. If A is negative, the parabola will face down. There's a cute way to remember this. If you draw an A, a lowercase a, kind of looks like a little girl with a ponytail. If A is positive, the little girl will be happy. It's going to be face up. If A is negative, the little girl will be sad. The parabola is going to face down. So the sign of A tells you whether it's going to be an upward facing parabola, U shape, or a downward facing parabola, mountain shape. Okay. So they'll often say maybe open up or open down, okay? Because if it opens up, it'll look like this, like a cup. And if it opens down, then it'll be like a mountain, okay? Our next vocabulary word is vertex. The vertex of a parabola is either the maximum or the minimum, depending on whether it's facing up or down. If it's facing up, then it's going to have a minimum value. And if it's facing down, it's going to have a maximum value. It's going to have a peak. And a vertex is always going to be an ordered pair. So a vertex can't just be one single number. It has to be an ordered pair because you're talking about a point on the graph. You're talking about that turning point of the parabola. So another way to think of vertex is the turning point of the parabola, okay? The axis of symmetry is the vertical line equation that runs through the vertex. So if I could draw a vertical line straight through the parabola, you would be able to fold it in half, okay? And we're going to see that with the example right here. That vertical line through which we could fold it and it would be symmetrical on both sides is called the axis of symmetry. And we just learned in our linear chapter that vertical lines are always x equals equations. So they're going to be x equals whatever that x value of the vertex is. So we're going to see all of that happen in this example. Here's a graph of a downward facing parabola. The fact that it's downward facing tells me that A must be negative. Okay, now that's a clue as to what the function would be of this graph. Okay, we're not given the function of this graph. We're only being given the graph here. But we know because it's face down that A must have been negative. I can pick out the other key features though. Another key feature is where it crosses the y-axis, the y-intercept. The y-intercept is going to be the point 0, 3. for this example because it's crossing the y-axis at 3. The x-intercepts, we know these definitions, are where the graph crosses the x-axis, and here's where we could potentially have more than one. In this particular example, I have 2 places where the graph crosses the x-axis. So my 2 ordered pairs will be the point -2, 0, and the point 6, 0. Because it's crossing the x-axis at those 2 x values. Now, this is new. Over what interval is the function increasing, or where is the function increasing? We do know the difference between increasing and decreasing. However, in both of the other types of functions we learned, exponentials and linears, they only did one of those things. Either it was an increasing function or it was a decreasing function. We don't have that here because a parabola does both. In this particular example, the parabola increases up to this point, and then it decreases after that point. And remember, we can tell by which way we're following it with our finger. So since we're following this upward, we know that it's increasing until we get to the peak. And then we start following it downward, so it's decreasing once we pass through the peak. I want to know the intervals where it's increasing. Well, it's increasing up to basically this line, right? That's where it stops increasing and then it starts to turn around. That's why we call the vertex the turning point up here. I'm going to do interval notation the way that I did it for domain and range, if you remember back when we did domain and range. There's an arrow on this end. This is going to continue the pattern of increasing as I come in from the left. So if I continued walking in from the left side, I would always be walking up. So I am increasing from -infinity. And when do I stop increasing? I stop increasing at 2. You're only talking about moving left to right. So you're only talking about x values here. You're not talking about y values, which is a very common error. So the x value where you stop increasing is going to be 2. We don't put square brackets on increasing or decreasing because it's not actually doing either of those things when you get to this point. Where is the function decreasing? Well, if I keep following this, I get past the turning point and then I start decreasing. So I start decreasing at that x value of 2, and I continue to decrease forever and ever and ever as I keep walking. So I keep decreasing until positive infinity. So your increasing and decreasing intervals are similar to domain and range, except you're only looking at the portions of where am I tilted upward and where am I tilted downward. But then you're going to use the same notations that you would for domain and range, okay, for your intervals. The only difference is that, again, we don't actually land at a point when we're increasing and decreasing because you're not going to increase or decrease at that endpoint. And finally, we're going to pick out the vertex and the axis of symmetry. Let's actually do the axis of symmetry first because we had to draw it in when we were talking about our increasing and decreasing intervals. The axis of symmetry is this vertical line that's passing through the vertex or the turning point. This vertical line is going through 2 on the x-axis. So this is the equation x equals 2. Because everywhere along that line, the x value will always be 2. So it's an x equals equation for a vertical line. The vertex is this ordered pair. That ordered pair is the point 2, 5. And it's just where the maximum is in this particular example. So that's how you pick out all of the important features of a parabola. Now, there is a way to calculate the axis of symmetry and the vertex algebraically, but it requires a formula. So we are learning a new formula here. X equals negative b over 2a is our axis of symmetry formula. So if I want to find the axis of symmetry, all I have to do is identify my a, b, and c from the quadratic and use this formula. Yes, it is a formula that you're going to have to just know, okay? So the more you practice it, the more you will know it, the more you will internalize it. So let's see how this works. We're going to use the function f of x equals x squared minus 2x plus 3. And let's compare this to ax squared plus bx plus c. In this example, a is 1, b is negative 2, and c is 3. So the axis of symmetry formula is x equals negative b over 2a. So I'm just going to substitute what I have here. The b is negative 2. So it's negative 2, because remember, you plug in with parentheses, over 2 times 1, because 1 would be our a. And now I'm going to evaluate the numerator and denominator separately. Minus minus becomes plus, so that's a positive 2. 2 times 1 is just 2, and now I can divide, and 2 divided by 2 is 1. So now I know that the axis of symmetry is x equals 1. That doesn't complete the whole picture for me, though. I want to find the vertex. But I know that the vertex shares this x value because the axis of symmetry goes through the vertex. So I'm going to take this x value and I'm going to plug it back into the function. So the original function was f of x equals x squared minus 2x plus 3. I want to find f of 1, and I'm going to plug this right in for x. So this is going to be 1 squared minus 2 times 1 plus 3. And remember, plug in with parentheses. As I evaluate this, and you can use your calculator to evaluate this, you wind up with f of 1 equals 2. So now I just found the ordered pair 1, 2. When my input is 1, my output is 2. And so I just found that the vertex is the point 1, 2. You can prove all of these things to yourself if you graph it using technology. So if you have a graphing calculator with you at home, you can use that and you can plug the function into y1. If you're using Desmos, you can plug the function into Desmos and it will show you the parabola. And last but not least, talking about the features of a parabola, there are 3 possibilities for how many places it can touch the x-axis. So there are zeros, which are essentially the x-intercepts. I'm going to talk about a few different synonyms, okay, that you could see when we get to that, that part of quadratics. But this is one particular scenario that could happen where it just hovers. This is hovering above the x-axis. It's not touching it. And this is below the x-axis, and it's not touching it. If it doesn't touch the x-axis, there are no x-intercepts. So these would be examples of having no x-intercepts. However, I would still be able to identify a vertex in each scenario. And I would still be able to identify a y-intercept eventually in each scenario, okay? But it's not going to ever touch the x-axis. In these two, they just like touch down on the x-axis. So they're only hitting the x-axis at one point. So these would be examples of the parabola only having 1, 0 or 1 x-intercept, because it's just touching down right here at the vertex, and it's just touching down right there at the vertex. So in these scenarios, the x-intercept is the vertex. They actually are one and the same. And then your last scenario probably happens the most often, is that it crosses the x-axis twice. So here we have 2 x-intercepts, and here we have 2 x-intercepts. So these are the 3 different orientations that you could potentially have for a parabola. Now let's do a few more examples where we find all of the important features using the equations. We want to identify the y-intercept, the vertex, and the general shape of the function f of x equals negative 3x squared plus 15x. The first thing that we're going to do is compare this to ax squared plus bx plus c. The a value is negative 3. The b value is 15. And there is nothing here for c. If there's nothing here, it's just like there would have been a plus 0 there, because that does not change the function. So my c is 0 in this example. Now, it turns out that when you plug 0 in for x, because remember, the y-intercept occurs when x equals 0. If I plug 0 in for x, I would always wind up with c. So it turns out that c is always our y-intercept 0, c. And that's the same type of thing that we saw in linears. B, that constant term, was the y-intercept. Here, this constant term is the y-intercept. So I can now say that the y-intercept of this particular function is 0, 0, because that's my c value. What else do I know? A is negative here. So what does that tell me about how the parabola is going to face? The parabola is going to open down because A is negative. So I should be able to start picturing this. I can picture a downward facing parabola that's going through 0, 0 on the graph. Now I want to find the vertex. The vertex formula is to first find the axis of symmetry, which is x equals negative b over 2a. In this example, it's going to be negative 15 over 2 times negative 3. This is going to give me negative 15 over negative 6. Remember, you have to evaluate numerator and denominator separately first. And this is going to give me 15 over 6, which will simplify to 5 over 2, or 2.5. And it is okay to use decimals when it comes to quadratics. So I have the x value of the vertex being 2.5, or in other words, I have the axis of symmetry being x equals 2.5. Remember, this is only half of my axis of my vertex. My vertex is going to need the y value for this input. So I also need to find f of 2.5. So everywhere I see x, I'm going to plug in 2.5, and then I'm going to use my calculator to work that out. When you work that out, you wind up with 18.75. And now I have the ordered pair 2.5 comma 18.75 as my vertex. Will this vertex be a maximum or a minimum? Well, let's see if we can put this all together. It opens down, which means it's going to look like this, which means there must be a maximum. So this vertex is going to be a maximum because of the orientation of the parabola. With all of this information, I can start to make a quick sketch in my head. I know that it goes through 0, 0. I know that it goes through 2.5 and 18.75 as a vertex. So 2.5 and 18.75. Doesn't matter if it's accurate or not. I just want to make a quick sketch. And I know that it opens down. So I can picture something that looks like that. And like I said, this is a rough sketch, but knowing that this is the axis of symmetry, it has to be symmetrical around that line. So this would be a rough sketch of that. You can verify all of that on your graphing calculator or on Desmos or some other technology. Let's do one more for this video. Identify the y-intercept vertex and general shape of the function f of x equals negative 5x squared plus 4. Let's do the y-intercept first. The y-intercept occurs when x equals 0. It's always going to be the c term. So the y-intercept is going to be 0, 4. Which term is missing from this expression? It's that x term that's missing. So if I had to rewrite this, it would be negative 5x squared plus 0x plus 4. So it's the b term that is now 0. If I had to look and see which way this was facing, my a is negative. If a is negative, that means it opens down again. So we're talking about this shape again, downward facing parabola. And last but not least, I have to determine the vertex. So x equals negative b over 2a. We'll find my axis of symmetry. So this is going to be negative 0 over 2 times negative 5. But that's going to be 0 over negative 10, which is just 0. When x is 0, I technically don't have to do the work here because I already determined that my y-intercept when x equals 0 is 4. But if I wanted to show the work, I want to find f of 0, which means I'm plugging 0 in everywhere in the original function. That goes away, and I wind up with 4. So now I know that 0, 4 is also my vertex. So this tells us a few things. First of all, if there's no b term, your vertex is going to be your y-intercept. Guaranteed, okay? Because the work is always going to happen like this, where you're going to get 0 for your input. It also tells us that we're not going to have enough information to know exactly what this looks like, because I don't know where the other points are on the parabola. if I only know that the y-intercept is 4 and the vertex is also 0, 4, all I know, if I made a quick sketch, all I know is that this is the maximum value and the y-intercept. I have no idea how wide the parabola goes. Is it a fat parabola? Is it a thin parabola? I have no idea. All I know is that it's going to do that. And I have no idea what those two x-intercepts are going to be. So unfortunately, this doesn't give us enough information to get a really good sketch in mind. You would have to turn to your technology at this point to figure out what the x-intercepts might be. And we will be learning how to find the x-intercepts in a later video. But right now, it's just about the y-intercept, the vertex, and the general shape. So let's do a quick summary of what we saw in this video. We saw that f of x equals ax squared plus bx plus c is the general form of a quadratic. We saw that the c value is the y-intercept 0, c. We saw that the a value tells you if you're face up or face down. If a is positive, parabola opens up like this. If a is negative, the parabola opens down like this. Okay? And last but not least, we saw that the vertex is always negative b over 2a for your input, and the function evaluated at negative b over 2a for your output. So in other words, x equals negative b over 2a finds the axis of symmetry, and then plug in that x value to find the corresponding y value. To the vertex. And that's a short summary of all the aspects that we saw in this video. If you have any questions, always contact me and I'll be happy to answer them. Have a great day.